Hello, hello, hello. How's everyone doing today? Welcome from Willow Spring, North Carolina. The dream is now over, Melody. I am back from South America and I am sitting here freezing my butt off in Willow Springs, North Carolina. How's my sound right now? Quick sound check. Can everybody hear me? Can everybody hear me? How's my sound coming through this morning? Looks like it might be a little bit low. Let me turn it up and see if I can get any better sound. How's that? So yes, Melody, I'm hoping to one day move to a digital nomad status and move around the world visiting places while I work. So that was just a test run I did in January to make sure my technology worked well. Did everybody have a good experience this past January? Were you able to contact me well enough? Um, did the lectures come through clear enough? Did you feel like I was there with you? Hello, Anna F. Good morning to you as well. Good morning to you as well. Fantastic. Good crowd today. All right. And the sound is going well. So let's go ahead and get started with today's lecture. Okay. So, boom, look at this. I've got the screen behind me, the green screen. So, good. I'm glad you didn't. So now I'm going to be able to appear in front of different screens on my internet. So here we are in front of my Blackboard PowerPoint. And then I'm going to jump back up here. You look at my office here. I've got some books on the wall. Okay, yep, great. Yeah, everybody's starting out on February. I hope everybody's having a great February. All right, let's go ahead and get started. So this is chapter 4. This is the densest chapter of the entire book. This is probably the meatiest subject in psychology. And if you're going to take another psychology class and you really want to learn about human beings, do not take abnormal psych. Do not take social psych, which is my specialty. Instead, take developmental psych. It is the meatiest uh, 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 content area of psychology. It's really like a user's manual for how to be a happy, healthy human being. So, if any of you are thinking about taking a class, I teach developmental psychology, Psych 241 in the fall, and I would love to have you students in my class because this is a great class. This is all about development and how you can grow up to be the happiest, longest living version of you that exists. I'm still not going to get through all this stuff because this is such a meaty chapter, but I'm going to try to hit the high spots for you. So, what we're going to cover today, we're going to talk about why the developmental perspective is important. We're going to talk about how we have healthy babies. We're going to talk a little bit about language milestones, and then I'm going to try to talk about Piaget's theory of cognitive development. But to be quite honest, we're probably going to run out of time before I get all of Piaget in there. All right, so let's go ahead and get started. Now, why do we care about human development? You know what? Human beings are a crop. And just like if you want to grow a good crop of corn or a good crop of beans, if you want to grow a good crop of human beings, you need to know what the conditions are that promote healthy growth for those human beings. You need to know what the dangers are for those human beings. And so, learning about what humans needs allows us to create the conditions for healthy growth. Quick example, average lifespan is the age at which 50% of a given cohort will die. So I was born in 1969. If my average lifespan is 72 for an adult male, that means 72 years after 1969, half of my cohort will be dead. All right. Now, the average lifespan today is around 79. If you compare that with the average lifespan in 1900, the average lifespan in 1900 was 47. Infant mortality was relatively high, and very few of us lived to be older than 65. Now, the average lifespan is 79. We have a relatively low infant mortality rate. We use seat belts. We do all these things that keep people alive and safe. And 15% of our population is older than 65. Did you know that they think that in 2030, in some parts of the world, the average lifespan is going to be 90. 50% of us are going to live to be 90 years of age. All right. So here's the deal. Think about that. Half of us were dead at 47 in 1900. Now, in 2030, half of us will still be alive at age 90. Where does that improvement in our lifespan come from? It comes from developmental psychology. Lifespan development is the multidisciplinary study of how people change over the course of their lifespan, from conception until death. Yes, we're going to talk about prenatal development too, because that's where you get a good start in your mom's womb. Okay. Now, we're going to talk about development. What causes people to develop? We're going to differentiate between two things, nature and nurture. Nature is the genetically programmed maturation that occurs in your body. We all go through puberty somewhere between 10 and 13 years of age. Why does that happen? Well, it's a maturational thing. All of us are going to get gray hair when we're 50. Why does that happen? Is it your environment? Nope, it's just a genetically programmed change that occurs in you. So, we're going to talk about maturation or nurture, and we're going to compare that with the effect that your environment has on your development. So there are two things that cause you to change. One is internal forces, your maturation, your genes, and the second is the environment in which you live in. Now, here's the deal. Studying human development is a really big thing. So, in order to sort of give it some organization, psychologists or developmentalists typically study human development in three broad domains. That is, how do we change? Um, these domains are physical, cognitive, and socio emotional. How do human beings change? Well, number one, we mature physically. We're going to talk about how the brain develops. Through your first 2 years, especially, we're going to talk about the brain development and the physical change that occurs as human beings grow up. So, we're going to talk about physical development. Human psychologists also study cognitive development. How does our mind change? What is the functional difference between a 2-year-old, a 7-year-old, and a 13-year-old in terms of their thinking abilities? I'm going to try to get to that at the end of class today. And then we also talk about how human beings change emotionally. How does their personality change? Did you know your personality is fairly flexible until you reach 18 to 20 years of age? Then your personality traits sort of set in, and that's you for the rest of your life. That's socio emotional change. So human beings change along three broad dimensions. We change physically, we change cognitively, and we change in personality. So the study of human beings is sort of broken down into these three broad characteristics. How do these three broad characteristics change from conception through death? Now, what we're going to do today is we're going to talk a little bit about physical development, and I'm going to try to talk a little bit about cognitive development, and then we're going to leave socio emotional development for Thursday. Am I making sense right now? Is everybody following me? Is this interesting right now? Please give me a little quick feedback in the chat bar so I know how I'm doing. Okay. Now, development begins for birth. Before birth, what you do, and I hate to say this puts a little more pressure on females than on males, but what you do while you have a baby developing inside you really does affect what affects your baby's development. All right, now we have an umbilical cord, and between the mother and the baby, their blood, actually, the developing baby's blood system is separate from the mom's blood system. But what happens is the capillaries of the mom in the placenta run next to the capillaries of the babies. And through these capillaries, they have interstitial spaces, spaces between these capillaries, and small molecules like oxygen and salt and water can seep from the mom's blood system into the baby's blood system. And that's how the mom feeds the baby during development. But because the two systems never touch, what happens is big molecules, dangerous molecules that could hurt the baby, are not able to seep through the mom's capillaries. And so there's what we would call a maternal blood filter that protects a developing baby from some of the harmful things that a mother might ingest. However, there are molecules that are small enough to seep from the mom's blood system into the baby's blood system that can harm prenatal development. So, if you're drinking alcohol, if you're taking prescription drugs, if you're taking some sorts of acne medication, these chemicals, these molecules, are small enough to seep into the baby's blood system, and they're what we call teratogenic. Teratogenic. Now, what I want you to do today is to talk to you and to suggest to you that as you develop inside your mom's womb, um, you have to protect yourself from these teratogens that can affect the mom's prenatal development. In 1900, we didn't know this, so moms would often ingest things that might harm their baby, right? Now, prenatal development occurs in three broad stages. There's the germinal period, the embryonic period, and the fetal period. The germinal period is the first 2 weeks of prenatal development, and it's when the egg is fertilized by the sperm and implants into the uterine wall. The most likely thing to happen during this stage is that the little zygote doesn't form properly and it doesn't implant into the uterine wall, and the baby may be miscarried. Okay, now, after the first 2 weeks, when the fertilized egg implants in the uterine wall and the nervous system begins to develop, the baby goes into what we would call the embryonic period. And this lasts from about 3 to 8 weeks. Now, why do we care about this? Well, we differentiate this from the other two stages because this is the stage in which organogenesis occurs. All of your organs, from your kidneys to your brain to your arms and legs, begin developing between 3 and 8 weeks of prenatal development. If you look at this picture underneath me, you'll see how we've got this chart of a baby's development into the germinal period, the embryonic period, and the fetal period. Now, what I want you to notice is that each of these bars represents a different organ system: the central nervous system, the heart, the arms, the eyes, the legs, the teeth. Uh, the external genitalia, the ears, all of your organs begin developing sometimes between 3 and 8 weeks. This process is called organogenesis. Now, if you ingest a teratogen during this stage, your baby may be miscarried, or your baby's going to have birth defects. Some of these organs aren't going to grow properly, and they're going to be misshapen. Okay, so the embryonic period is the next few weeks. Now, if you look at these bars, you're going to notice that these bars have a beginning part and an end part. So, your heart, for example, starts developing during the third week, and by the 10th week of prenatal development, your heart is complete. Okay, the same thing with your legs. They start in the fourth week, and by the 10th week, your legs are fully formed. They're done. They're not as big as they're going to get, but they're fully formed. Now, you'll notice some of these bars keep going on. So, the teeth, for example, aren't fully finished until about 20 weeks of prenatal development. And if you'll see the central nervous system, you'll notice that it's not fully formed even when you're born. Did you know your brain does not fully mature until you are 25 years of age? So these organs begin developing between 3 and 8 weeks of prenatal development, but some of them won't finish until you're a grown adult. Now, you'll notice that we have these bars have a green period, a green part, and a purple part. The green part represents when these organs are most sensitive to teratogens. And if they are exposed to teratogens during this period, these organs oftentimes will demonstrate major structural defects. Okay, you'll have birth defects. So this is when a teratogen might be introduced. Now, from 8 to 40 weeks, most of the systems are matured or are fully maturing, and this is when the baby really grows and gets big, gets gains that baby fat that's going to help them survive outside of the womb. And this is from 8 weeks until the baby is born. Now, smoking or other teratogens during this period might cause the baby to be born early or of low birth weight. And low birth weight babies have lots of problems throughout their, are more likely to have problems throughout their life. The baby may still have a birth defect, and it's less likely that the baby's going to be miscarried at this stage, but it still can happen. Now, why do you tell me this, Chris? Well, the reason that we've increased the average lifespan here in the United States and across the world is because we know that you have to protect babies before they're born. You have to protect them from teratogens. And so scientists have spent a lot of time trying to figure out what things can harm a developing baby. There's a list of these items in your textbook. I expect you to go over these items and know a little bit about the effect of alcohol and nicotine and some of these other drugs on the developing baby. Okay, now what determines the impact that a teratogen will have? Well, it depends on how much of the teratogen you ingest. It depends on the genetic susceptibility of the baby. And as I suggested to you, embryonic or fetal period, it depends on the timing of this dose. It's hard to say whether or not one cigarette or six drinks is going to harm your developing baby. It depends on a lot of things: how much, when you do it, and the genetic susceptibility of the baby. But what we do know now is that you, as a mom, when you have a baby, in order to give your baby the best chance of being healthy, it's important that you avoid certain types of substances while the baby's developing. Does that make sense? Now, see, I know this doesn't sound like psychology. Like I said, developmental science is a multidisciplinary thing. We have doctors, sociologists, anthropologists, and psychologists. And one of the things that we know about helping people live longer, healthier lives is what to do before the baby is born. Hi, Cosette. Good to see you. Thanks for coming today. Okay, now here's the deal. Let's talk specifically about psychology. How does the brain grow? Because that's what I'm interested in. This is a developmental psychology class. And like I said, when we were talking about the subfields the other day, I said developmental psychology. Developmental psychologists are interested in how human beings develop their abilities. And all of this is tied to the brain. If the brain doesn't change, your cognitive abilities don't change. If the brain doesn't change, your socio emotional abilities don't change. So, when we talk about the changing qualities of the brain, we are talking about biological development. How does the brain change? Well, there are two kinds of neurological changes in the brain. One is represented with learning or environment, and the other is related to your nature or maturation. Now, how does the brain change as we grow up? You know what? I probably should have maturation up top. So I'm going to start with that. How does the brain change in a programmed way? So, when your brain is born, if you'll notice, human beings are very, very helpless compared to the adult of the species, right? If you've ever been on a barn, on a farm, you might see a chicken be born or a rabbit be born. And what you'll notice is that these animals quickly start moving around and acting just like the adults. On the other hand, human beings are quite helpless for many years of their life. Why? It's because their brain isn't fully developed. What's missing in the human brain? What's missing is myelin tissue. Remember in chapter 2, I talked about glial cells, the support structures for neurons, and they form this stuff called myelin. Well, what's missing from your brain when you're born is myelin tissue, this fatty tissue that surrounds and insulates your axons. This tissue comes mostly after you're born. It comes in a genetically programmed way, and as parts of your nervous system myelinate, you become mature. Your ability in using that part of your brain matures, if you will. Exactly. Like the girl in chapter 4, how she stayed like a toddler and never changed. Yes, she had a developmental problem. Very good point, Cosette. Thank you. Thank you. Now, this programmed genetic change is caused by the growth of myelin tissue around your axons. Now, a large part of this myelination occurs during the first 2 years, and that's, if you'll notice, that's when human beings change the most. They go from helpless infants to little human beings that can walk, talk, use their arms and fingers, and have sort of and start to look like little people. And so this myelin tissue, as it grows, the baby's ability matures. Now, during the first year of life, they tell moms to drink or to feed kids when they do get them on regular cow's milk, to feed them for the first 2 years, not low fat milk, but regular milk. And it's because that extra fat in the milk is helpful in building the myelin tissue that helps mature the brain. Now, it occurs in a programmed fashion and it leads to the emergency of abilities. Some parts of the brain myelinate earlier than others. What typically the myelination is going to go from the back of the brain forward. So your visual centers, your motor cortexes, your sensory cortexes, your memory, they are all going to myelinate before this prefrontal cortex. And that's why 13-year-olds have bad judgments. You ever notice that 4 and 5-year-old kids throw temper tantrums and can't control their emotions? It's because their frontal lobe hasn't matured and they can't control the emotions that they feel like us older people can. You ever notice that 3 and 4-year-olds are not very agile and they don't have good hand eye coordination? It's because the motor and sensory cortexes in the cerebellum haven't fully myelinated yet. And as these structures myelinate, our abilities become matured. So, this is how brains develop, and this is program change. And you'll notice that on this picture right beneath me, they show you which parts of the brain myelinate first and which parts of the brain myelinate last. The parietal area that you see myelinates last is your critical thinking ability, your spatial ability, your mathematical sense. You'll notice that underneath your memory on your temporal lobe myelinates last, and you see that your prefrontal cortex myelinates last. What myelinates before that? Your vision center becomes mature, and your motor and sensory cortex is myelinate before. And this is why abilities emerge in a very predictable fashion in human beings. Okay, now the second change is what we would call learning or dendritic change. When you stimulate a brain, remember I talked about the dendrites and the terminal buttons, and they're sort of these branch like structures. When the presynaptic neuron stimulates the postsynaptic neuron secretes chemicals that causes the presynaptic neuron to grow, kind of like the postsynaptic neuron fertilizes the presynaptic neuron. And so as one neuron stimulates another, they grow towards one another. They start to grow more connections. This change is what we would call synaptic blooming. Synaptic blooming. So, whenever you stimulate a brain, the little dendrites grow in whatever area is being stimulated, the dendrites grow, and you get these connections between neurons. Now, if you look at that chart on the bottom left hand side of the screen, what it's going to show you is 10 neurons, and at birth, you see these neurons don't have many connections, but you'll see at 6 years of age, there are lots of connections. So these same number of neurons, but they've grown more connections. And you see how it looks really dense there? Now, what's going to happen is when you stimulate your baby by talking to your baby, by showing your baby things, by playing patty cake with your baby, you're stimulating that brain and causing dendrites to grow. This is learning or this is learning or environment, if you will. This is nurture, not nature. So one of the things that you have to do for your baby, you don't have to teach them math or calculus or a foreign language. All you have to do is play with your baby, stimulate their little brains, because when you do, these dendritic uh, uh, connections grow. Now, the cool thing is your brain grows more connections than it will really need. It will grow multiple connections for the same ability. And then after a while, it'll find out which one of those connections works the best, and it'll start using that one connection. And what happens is the unused connections will then die. When neurons don't stimulate other neurons, the connections die and go away. And so what happens is as you stimulate your baby's brain, it's going to grow pathways and connections that allow it to use its brain most effectively. All right. And the death that occurs in these dendritic connections is sometimes called pruning. So, what happens to a brain as we stimulate it during the first 10 years of life is it grows a unique architecture that connects the different parts of the brain in whatever way works best for that brain. It's called synaptic blooming and pruning. And what this does is this creates a brain that is programmed to work the best it possibly can. Now, in order for human beings to grow normally, they need stimulation during critical periods. What's a critical period? It's a time during your development when an ability needs to be stimulated in order for it to work. In order for your visual center to work properly, the first several months of your life, you need visual stimuli to grow the connections. Uh, People play music for their baby. You know what? That is helpful too. The effects of that are a little less clear melody. It's stimulation. It's not a bad thing. Babies seem to know their mother's voices when they're born, so we know that they hear in there. And there's this thing called the Mozart effect, where they think that classical music increases people's mathematical ability. And so there are lots of questions, Melody, but nobody's really sure if that music has a long lasting effect. That's a great, great question, though. That's a great question. Now, here's the deal. I think there's a girl in your textbook called Jeannie, the wild child. Jeannie was brought up in California by an abusive, crazy father who pretty much locked her in a bedroom the first 11 years of her life and did not let anybody talk to her. She grew up without language for the first 11 years of her life. He had her chained to her crib and he would feed her through the door. And for 11 years, she never had anybody to talk to. Now, social services and the police discovered this at 11 years old, of course, arrested him and rescued Jeannie. And psychologists used this as a case study. Yes, it is heartbreaking, isn't it, Nicole? Can you believe somebody would be that evil to another human being? But she provided a case study, an experiment that can't be done ethically, but if it happens, you can find out what the situation is. And what psychologists realized was Jeannie was unable to learn a mature language. She couldn't figure out how to use grammar to create a mature, complex language. She had missed her critical period for language. All right. And so, what I want you to know is that there are critical periods for vision. There's critical periods for developing trust in human beings when we have what's called the attachment period. There's critical periods for developing personality. And so, different parts of the brain have to be stimulated at certain times in order for normal development to occur. Yeah, it won't thrive and it can die. But if it does live, it will be profoundly damaged, Cosette. During your first year of life, you learn how to bond with other human beings. It's a process called attachment. If you're isolated and neglected during this period, you'll develop something. You can develop something called reactive attachment disorder, and you'll be unable to bond with other human beings, and it makes for a terrible life, but we'll talk about that later. Now, what I want you to know is this specialized growth that happens in each and every one of your brains leads to a quality of development we call neuroplasticity. The brain is flexible and it can actually rewire itself in case of brain damage. So if you damage your brain young enough, the brain can rewire itself to overcome that. I don't know if any of you saw the video of, we're going to watch that next week, Ben Underwood in chapter 5. This is a guy who lost his eyes to cancer at the age of 3, and he learned how to echolocate with his ears so that he can, quote, see with his ears. And this guy runs around doing what everybody does normally, playing basketball, riding a bike, skateboarding, because he makes noises and echolocates in his space. His brain was able to rewire to the loss of his eyes, and he uses his visual system to echolocate and see with his ears. This quality of the human brain is called neuroplasticity. And sometimes I meet students who were born without a part of their brain, and their brain has been able to rewire itself so that they grew up with all of the normal abilities. This occurs because of synaptic growth, synaptic blooming, and pruning during critical periods of development. Is this making sense to everybody? Am I boring you yet, or are you finding this interesting? These are the two qualities in how human brains change. So, part of it's maturation and genetically pre programmed growth. All right. And then part of it is environmental stimulation. So, when you go to Walmart next time looking for a toy for your newborn cousin, and you go into the aisle where it says educational toys, and you see the toys for the 1 year old, and they're just lights and flashing things and colors. Basically, education at below 1 years of age is just stimulating the brain. I've heard that people with autism undergo less synaptic pruning. You know what, Eli? I have not heard that. That could definitely be true, but I don't know that. I will look that up so that I can speak more intelligently about that next class, Eli. Thanks for bringing that up. So, if the critical period is missed, a person cannot learn language at all. Pretty much so. And you know what? Here's a crazy thing. There is actually a critical period for hearing language. I think it's in your developmental four chapter. It turns out that you learn uh, that each language makes different sounds. So when I was down in Spanish in Colombia, I was trying to roll my R's, and I couldn't do it. And people would laugh at me when I tried to say carrera. Um, that's a sound that's not made in the English language. And what happens is, in the first year of your life, by hearing your native tongue, you learn what sounds are used in your language and you become deaf to the sounds that are used in other languages. And so this is a period when we go from what they call universal linguists to specialized linguists. If you don't let a baby listen to Mandarin Chinese before 10 months of age, that baby will not be able to hear sounds in Mandarin Chinese that are not used in English. Okay, and the same with the other babies. So, critical periods, yes, they are for hearing, they're for seeing, um, they're for personality, they're for language. Yeah, great question, Sandra. All right, now here's the deal. It's expensive to see the growth of myelin tissue. You can actually use MRI scans and other brain scans to see whether or not a brain is myelinating properly. In fact, they can even sort of guess your age based upon how your brain is myelinated and what parts of your brain are myelinated. However, insurance companies do not want to pay for these expensive brain scans to evaluate children's development. And so, what we've developed is a way to measure a brain's development without actually going into the brain and imaging it. We can instead look for milestone behaviors that tell us that that brain is growing normally. Okay. So, yeah, okay, Sandra, if your kids heard Finnish and English, they will be able to speak fluent Finnish and sound like a Finnish person. Whereas for me, I'll never be able to sound like a Finnish person because I didn't hear the language at the right time of my life. Now, here's the deal. This fellow named Arnold Giselle in the 1930s figured out this really cool idea. He had this great insight. It turns out, and probably moms have probably known this, parents have known this for ages, but babies' abilities across the world unfold in the same basic order. All babies learn to hold their head up first. Then all babies learn to roll over about 3 or 4 months of age. All babies begin sitting without support at about 5.5 months. And if you look at all, quote, what we will call normal babies, you will see that their abilities unfold in a very predictable fashion. And so what Arnold Giselle did was he evaluated tons and tons of healthy babies to find out when these babies usually develop these abilities. And these typical abilities are called milestone behaviors. And what he realized is that you can compare your baby to these averages to see if your baby is developing normally. And if your baby is not making milestones, for example, you can diagnose a child at 1 years of age with autism if they're not hitting their social milestones. Um, and so you can use these milestone behaviors to compare your baby to see if your baby is developing normally. Now, what in a sense you're looking at is whether or not the myelination and the dendritic blooming and pruning is occurring normally, but you don't actually have to go into the baby's brain. You can get a first clue by looking at these milestone behaviors. And what we see is that children are born with a certain set of behaviors and then they develop other behaviors as they grow up. Now, babies are born with a set of reflexes. When your baby's born, there are a certain set of infant reflexes that protect that baby until they start to develop their voluntary motor abilities. Your baby has a sucking reflex. Your baby will have a rooting reflex that looks for a breast to suckle on. Your baby has a startle reflex. When they're scared, they reach out and grab to hold on to their mom. And so babies are born with reflexes. And as they develop these voluntary behaviors over the first year of life, these reflexes go away. And so, what you can do is you can evaluate your baby to see if there's hitting these milestones. Now, here's the deal milestones typically happen in a predictable fashion. Now, some babies, just like some people are always late to a party and some people are always early to a party, some babies are going to hit their milestones late. Now, it doesn't matter and when you take your child to the pediatrician, your pediatrician is going to ask you questions and do interviews, and what they're listening for is milestone behaviors. Now, if your child is hitting every milestone a month late, that's not a big deal. The key that the doctor is looking for is a steady progression through milestones. So your kids should raise their head around, be able to hold their head up around 2 months, maybe 3 months for your baby, maybe 1 month for another baby. Then your baby should learn to roll over sometime around 3 or 4 months and develop the trunk ability to roll over. And so the doctor, when you go to the pediatrician, they may give you a form, an official form to fill out, or they may just do an interview. And what they're listening for is your baby's milestone behaviors to be occurring. Does that make sense to everybody? Now, what are the different categories of milestone behaviors that your doctor is evaluating? Well, the doctor is looking at your baby's gross motor behaviors. Do they have control of their trunk? Can they support some weight with the legs? Can they use their big muscles? Okay. Then the doctor, as your baby hits 1 to 1.5, the doctor is going to be looking for fine motor ability, the ability to hold things with these two fingers. Because in order to do well in school, you need to be able to hold a pencil and write sentences and whatnot. So you have fine motor abilities. Cognitive abilities. Your doctor is going to look to see, do you understand the word no? Can you follow an object with your eyes? Do you have the normal developing milestone intellectual abilities? Does your baby have socio emotional abilities? So we can diagnose autism because you're supposed to develop your social smile at around 3 months. The baby then starts smiling when it gets tickled. If your baby doesn't develop a social smile, the ability to smile, or an interest in human beings by about 7 or 8 months, your doctor may begin to suspect that the child has autism. So we have socio emotional milestones, and then we have language milestones we're going to talk about on the next slide. And so, what a doctor, when we're talking about a child thriving, what they're supposed to be doing is their brain's supposed to be myelinating and growing dendrites in such a way that predictable big muscle behaviors, small muscle behaviors, mental behaviors, emotional behaviors, and language behaviors should occur at very predictable times. Now, what we're going to do in lab tonight is I'm actually going to have you, when you come to lab tonight, we're actually going to look at some babies getting infant evaluations, and I'm going to see whether or not you can tell me that these babies are developing normally or abnormally and how their abilities are developing. So we're going to do some milestone evaluation in labs tonight. And so what we do is we expect that children should hit these milestones at predictable times. And if they don't, this is the first sign that there is a fundamental developmental problem with your child. Does this make sense, everybody? Okay. Now, one example of a milestone development that your book talks about is language development. Teachers look for milestones. They're, yes, absolutely, Claudia. They're going to be looking for different, more complex milestones. You're right. I didn't mean to short shrift the teachers. You're right. Okay, so teachers look for it too. Um, okay, great point. Now, there's this guy, Noam Chomsky, about 50 years ago, wrote this really cool book. No, God, it's actually been closer to 70 years now. Wrote a book called Syntactic Structures. And what Noam Chomsky suggested for the first time was that human beings have an innate ability to learn a language. I know this seems obvious to you now, but in 1950, this was a pretty profound concept. All right. Human beings will learn a language even without being taught that language. So if you think about this, everybody in the world, unless you have a developmental problem, everybody learns to speak a language during the first 3 years of your life. And here's the deal, nobody actually tries to teach you the language, you just automatically pick it up. And Noam Chomsky also realized that people all over the world hit these language milestones at about the same age, no matter what country they live in or what language they're taught. And so he came up with the insight that human beings have an innate potential to learn a language. And so he actually gave this a metaphorical name called a language acquisition device. There isn't actually a thing in your brain called a language acquisition device. This is more an innate potential to learn a language that all of us have. So if you were exposed to a language during the first 3 or 4 years of your life, you will learn how to speak. If you don't, you may not learn how to speak. But we all have this language acquisition device. And he suggested that this can show us that language is sort of an innate ability. Now, if you look at children, you will notice that children all over the world go through a set of language milestones, especially during the first year of life and over the first 3 or 4 years of life, as they learn how to use this crazy thing called language. And so, just for fun, just for giggles, I'm not having you learn any of the other milestone categories, but I'd be interested in you knowing the language milestones, what to look for in a baby. So, the first 2 to 6 months in your baby's life, you're going to see what we call cooing. Your baby's just going to make vocalizations. They're going to start making noises voluntarily. Now, these noises are not going to involve sharp sounds or consonants most of the time. They're really going to be practicing their vowels. They're going to be going ah, ooh, ah. And what you're going to notice is that around 4 to 5 to maybe even 6 months, your baby's going to suddenly start using their lips and their teeth, or their lips and their tongue, and they're going to start doing what we call babbling or practicing their consonants. Ba 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 ba, ga 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 ga, da 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 da. Your baby's going to start babbling. And so really what we expect to see in infants during the first 6 months of life is just voluntary vocalizations, either coos or babbling as they start to use their lips. Now, here's the deal. Children learn to understand language before they learn to use language. So we typically talk about Noam Chomsky. Actually, I'm sorry, I see a question in the chat bar. Eli. Yeah, Noam Chomsky is probably more well known for his political views now, but at one time he was a very famous developmental psychologist or linguist, I should say. So, yes, Eli, one and the same person. And we all have different opinions on his politics. So let's separate that out from his developmental psychology, can we? Okay, and so we're going to expect to see this babbling and cooing. Now, the crazy thing is, children should learn their name. Actually, this is more of a cognitive ability, and they should know words like no. And your kid's actually going to understand words. They're going to have latent language before they have what we might call extant language before they talk, but your kids are going to be able to understand you before they can talk. So, around 6 to 7 months, your child should start understanding things that you say. Now, what we're going to expect is that most children, depends, will say their first words sometimes between 11 and 13 or 14 months. Now, the crazy thing is there are differences depending upon whether how much your parents talk for you. So if your parents give you everything you want and you don't have to want for anything, and your parents are really hovering over you, you may not need to talk. You know what I mean? So the talk may be delayed. One of the things you're going to see, because females use more parts of their brain for language, is typically girls are going to say their first word before boys. So your girls may be 11 months, your boys may be 13 months. But sometime around the first year of life, your child's going to say their first word. My kid's first word, my oldest son, his first word was dog. Not dad, not mom, but dog. I was so freaking disappointed. I'm like, really? That's what you say at 12 months? All right. Now, around 18 months of age, your kid's going to experience what we call a vocabulary explosion. They're going to go from being able to say half a dozen to 10 words to all of a sudden, between the age of 18 months and 24 months, your kid's going to develop a huge, expansive library of words that they can say. And they're also going to begin putting two words together to make simple sentences. More milk, mommy, doggy. They're going to be able to say things and convey in the most simplistic of terms. They're going to be able to convey meaning through telegraphic speech. All right. And so this is how language develops. Your baby begins making vocalizations. Those vocalizations begin involving consonants and more well formed sounds. Then your baby's going to say their first word. Then at about 18 months, they're just going to get it, and they're just going to build this huge vocabulary, and they're going to start using sentences during their second year. And then from 3 to 5 years, your kid's going to develop the pragmatic ability, the ability to have a conversation, to understand that conversation involves me saying something, then you saying something, staying on topic and not changing topics randomly. Children will actually learn how to adjust their language for people who don't speak as well as they do. So, you folks all know, if you're speaking to a 2-year old, you can't use complex sentences. You all simplify your language because you know what that kid needs. These are all what we call pragmatic language abilities, and they begin developing in children from 3 to 5 years of age. Ashley Nicole says, my 2-year old went from babbling to vocabulary explosion within a month. Is it not freaking crazy? Because, like, if you're like me, Ashley, when your baby started saying words, you and the father probably counted the number of words that your kid could say. And every night, me and my wife would be like, he could say 6 words today. He can say 8 words. And we would gleefully count those words. And then suddenly he woke up on his 18-month birthday. And suddenly that vocabulary went from 10 words to like 50 words in 2 days. And then it just seemed like words were coming out of him. And so it's crazy to watch a vocabulary explosion during the second year of life. Great point. Great point. Okay, you know what? We're at 9:46. I'm not even going to try to get started on Jean Piaget because he's a long subject and I've only got 3 minutes before class is over. So I'm going to talk about that on Thursday. Uh, Deb Roy's Birth of a Word and a Study of His Child. It was a good example of how language develops over time. Claudia, that is a great point. And in fact, as I was talking, I was thinking about that, but I didn't want to bring it up. But thank you for bringing it up. You're absolutely right. Deb Roy showed the birth of a word and how parents simplified their language right as the word was being learned. That's an example of pragmatic language, and it's the example of this kid cooing and then babbling, learning how to use the motor aspects of language to then form these words. Great point. Great point. All right, folks. Now listen. Tonight we have webinar at 8 p.m. Don't forget webinar tonight at 8 p.m. And what we're going to do is we're going to break up into groups, and I'm going to have you watch videos of children going through developmental evaluations. and we're going to get you to try and evaluate these children to tell me what you think they should be doing and what they are doing and why you think they're developing normally or not. So we're actually going to practice a little bit of developmental assessments tonight in webinar at 8 o'clock. I really hope everybody makes it. Now, before I let you go, it's week 4. Exam week is this weekend. We have our first exam on chapters 1 through 4 this weekend. The exam will be available Friday morning at 9 a.m. If you want a review sheet, each weekly folder, there's a set of learning outcomes at the top of that folder. Put those together, and that equals your review sheet for this exam. Friday morning at 9 a.m., I will be holding a live exam review on YouTube, just like I'm having this class on YouTube. I will go over the exam question by question. I will say you need to know these 3 points from chapter 1, this from chapter 2. I am going to go over the exam live 9 a.m. on Friday morning. If you can't make it live, I highly encourage you to watch the review on recording, because it will become a recording after the live review ends on Friday morning. Okay? Uh, you know what? Does anybody have any questions before I let you go? Folks, this is actually my virtual office. You see behind me, this is what it looks like on my screen right now. I've got 3 monitors in front of me. I've got some lights here. This is my Willow Springs office. So, okay, I don't see any questions in the chat bar. So I'm going to assume that everybody has what they need for class. I look forward to seeing you tonight at 8 p.m. If you have any questions, don't hesitate to send me an email or a text. Take care and have a great day, okay? Bye.